do today is multiply fractions. And the thing that I really like about multiplying fractions as opposed to adding and subtracting is that we don't have to worry about finding the least common denominator. Let's get started with our two vocabulary words. We have numerator and denominator. Again, these are not words that are new to you, but they are important for this lesson. The numerator simply is the top number in a fraction, and because fractions are division problems, the numerator is a dividend, and it also shows the number of parts of the whole that we are using. And denominator. The denominator is the bottom number in a fraction. That is the divisor. And the denominator shows the number of parts that are in the whole that we're dealing with. And we are going to be working with numerators and denominators as we work through our 4 examples for today. In example 1, we have to just simply find the product. Here we have a negative 4/15 times 10. Now you know that when we are working with fractions and whole numbers, what we are going to do is convert that whole number into a fraction, which simply is 10 over 1. We just put the integer over 1. We have a negative and a positive, so I know that my answer is going to be negative. And then I fill in my fraction bar. Now let's take a look at this. When we are multiplying fractions, there are 2 things that you can do. You can either multiply the numerator straight across and then multiply the denominator straight across. We'll do that. A negative 4 times positive 10 is negative 40. And 15 times 1 is 15. We have 40 over 15. That is not its simplest form, so this has to be a mixed number. 15 goes into 40. It's going to be negative twice, which gives us 10 left over, 10/15. This 10 and 15 can be simplified, giving us our final answer of negative 2 and 2/3. So that's one way. Again, to repeat, multiplying the numerator and then multiplying the denominator. There is another way to go about this, though. Okay, going to draw a negative symbol at our fraction bar. Now what we can do is take care of our simplifying before we do our multiplying. And we have to work, it's called cross-simplifying. Now some teachers use the term reduce. And I don't like that because we're not reducing anything. We are just simplifying. We're making equivalents. We're not making anything smaller per se, except the factors that we're using to get our product. So we are cross-simplifying. So we look diagonally in our fractions to see if they have any factors in common. So let's start with the negative 4 and the 1. Well, we have a 1 here, so this won't be simplified any further. Then we look at our next diagonal. We have a 15 and a 10. 5 is the greatest common factor of 15 and 10, so here's how we do our simplifying. 5 goes into 10 twice, so I cross out my 10 and make it a 2. 5 goes into 15 3 times, and then we multiply straight across. 4 times 2 is 8. 3 times 1 is 3. This becomes 3 goes into 8 twice, with 2/3 left over. So you can see we get to the same answer. It's just for me, I like this because when you do your simplifying beforehand, there's less fuss when you are getting your final answer. But it doesn't matter. Use whichever one resonates better with you. Now down here, we have a negative 7/12 times a negative 4/28. And the first thing I'm going to do is see if they have any simplifying that we can do. Are there any common factors? So I'll start here and look diagonally. We have 7 and 28. And you know, 7 goes into 7 once, and 7 goes into 28 4 times. You have to be careful that when you are cross-simplifying, you are dividing out the same factor. If you're using different numbers for each of the diagonal pair, then you're changing what the fraction is. And now we have 12 and 4. They do have a factor in common. The greatest is 4. 4 goes into 12 3 times. 4 goes into itself once. Now, because we're multiplying a negative and a negative, our answer will be positive. 1 times 1 is 1, and 3 times 4 is 12. So negative 7/12 times negative 4/28 gives us a positive 1/12. Okay, in the first part of example 2, we are working with mixed numbers. When we have mixed numbers, we do want to convert them to improper fractions. Remember, we take our denominator and multiply it to the whole number, and then add the numerator. So 3 times 6 is 18. 18 plus 1 is 19, and the denominator stays the same. 2 times 4 is 8. 8 plus 1 is 9. We're multiplying that by 9 halves. We want to see if there is anything in common between a 19 and a 2. There isn't. They're relatively prime, so we don't have to do any cross simplifying there. Here we have a 3 and a 9. We can. 3 goes into itself once. 3 goes into 9 3 times. 19 times 3 is 57. 1 times 2 is 2. 57 over 2 simplifies to 28 and a half, and that's our final answer. And sometimes you will have an expression that is like this. We have a fraction being raised to a power. Now, just to remind you, when we have a power, there are two pieces to it. There is the base and there's the exponent. The base tells us which number, what factor is going to be repeated. And the power tells us how many times that factor will appear in the expression. So our factor is 3/5, and we have to multiply it 3 times. So I'm going to write out my expression. And as you can see, anytime we look diagonally to see if we can cross simplify, we can't. We always have a 3 and a 5, so those are prime numbers. So all we can do is multiply straight across. 3 times 3 is 9. 9 times 3 is 27. 5 times 5 is 25. 25 times 5 is 125. And even though it looks strange, this is our final answer. 27 over 125. The numbers are relatively prime, so there's nothing more we can do with them. So now what we're going to do is multiply fractions that have variables in them. Notice the word is simplify, whereas in examples 1 and 2 we were told find the product. Because we have variables, there are an infinite number of possible answers. So all we can do is make it as neat and tidy as we can, simplifying. But the method doesn't change just because we have a variable this time. We want to first see if there's any cross-simplifying we can do, and as it turns out, we can't. We have a 2 and 3, those numbers are prime. And we have a 15 and a 4, those are relatively prime. The only factor they have in common is 1. So our only alternative, our only choice is to multiply straight across. Notice I wrote my negative symbol to remind myself that because we're multiplying a negative and a positive, our product will be negative. And just to sort of harken back to when we were first learning about multiplying variable terms and exponents, we deal with the coefficients separately. So we have a negative 2 times a 4, which gives us a negative 8. And then we have an m to the 3rd power times m. Now remember, and I know some of you were forgetting this, when there is no exponent there, when there's the absence of 1, we assume that it's a 1. When there's nothing there, we assume that there is 1 there. And when we are multiplying exponents, variables with exponents, the base is the variable, so I moved over my m. And when you're multiplying powers you have to add the exponents. So 3 plus 1 is 4. So just to recap, because I don't know if that was a little bit confusing, a negative 2m to the third times 4m to the assumed first power. The first thing we do is multiply the coefficients. A negative 2 times a positive 4 gives us a negative 8. And then m to the third power times m to the first power gives us m to the fourth power, because the base will stay the same, and we add the exponents. And now we have to take care of our denominator. 15 times 3 is 45. So we have negative 8m to the fourth power over 45. We have to take a look at the exponents, the coefficients, to see if there is any simplifying we can do. And there isn't. 8 and 45 are relatively prime, so this is our final answer. Now let's work down here. We're going to, again, follow the same steps. The only difference here is that the variable is in the denominator instead of in the numerator. So we're going to see if we can do any cross simplifying. We have a 6 and we have a 4. They do have a factor in common of 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. Now we'll look the other way. We have a 5 and we have a 10. 5 goes into 5 once. 5 goes into 10 twice. And now we just multiply. 3 times 2 is 6. 1 times 2 is 2. And now we have a to the second times a to the fourth. That becomes a to the sixth, because the base stays the same, and then we add the exponents. And now what we have is, we're going to look at the numbers, because they can be simplified, whereas up here they couldn't be. 2 and 6 have a 2 in common. 2 goes into 6 3 times. 2 goes into 2 once. And then we have an a to the sixth, which gets moved right over. And we can actually further simplify this if you wanted, because we have a 3 over 1. And as I told you in class, when you have a number over 1 or a term over 1, it is not in its simplest form. You have to get rid of it, because having 1 in the denominator keeps it one step away from its simplest form. So 3 over 1 becomes 3, and this a to the sixth stays exactly where it is, and this is our simplified form. And our last example today is going to be a word problem. It's pretty lengthy. I'll read it to you. So we have example 4. You have to paint a wall that is 8.5 feet high and 12 feet wide. The can of paint you have will cover 200 square feet of space. Do you have enough paint in the can to apply 2 coats of paint? Now, if you're not familiar with the phrase coats, or to apply 2 coats, it means to paint the wall once, and then when it's dry, paint it again. Each application of paint is a coat. So what I did on this next board is, well, it's exactly what I do in class at the board. I take out the information that we know so that we are not being muddled by all the words that tell the story. In this story, we know that we have a can of paint already that will cover 200 square feet of space. We know that the height of the wall that we want to paint is 8.5 feet high. We know the width is 12 feet. And one piece that I forgot, we want to know, do we have enough for 2 coats of paint? Well, the first thing we need to do is to see how much space we have on our wall. And that is synonymous with finding the area. When you find the area, you should always start with the formula. Since the area is what we're calculating, we keep our variable a. And now we'll plug in the numbers that we have. The length, well, it's called the height here, but it's 8.5 times the width of 12 feet. Now we need to make this a little friendlier. 8.5 will turn into 17 halves. We'll make it an improper fraction. We'll make our 12 a fraction and put it over 1. Now we can do some cross-simplifying. Not with the 17 and the 1, but with the 2 and the 12. 2 goes into itself once. It goes into 6, into 12 6 times. Oops. 6 times 17 is 102. We can't forget our units. Square feet. So in order to paint this wall one time, we need paint to cover the area 102 square feet. Now let's take a look back at the can of paint we have. This can of paint covers 200 square feet of space. Now if we've applied 2 coats, we'll need enough to cover 204 square feet. So the answer is no, we do not have enough paint to put 2 coats on our wall.